In this video, we're going to find the distance between a point and a line. Before we actually get into the objective, we need to go back over some things that you've previously learned. This is from Algebra 1, solving systems of equations. So when we have two linear equations or just any equations, the solution to that system is the point or points of intersection between those two equations. So here we have two lines, and we know two lines are going to intersect at a point. So the intersection there is going to be our solution. So we have the lines 2x minus y equals 9. Okay, that's our line A here that I've highlighted. And then our line B, that's 3x plus 4y equals negative 14. This is line B. And then we found the intersection of those lines as point A. And graphically, it's the point of intersection at 2, negative 5. Now, if you want to go back over how to solve systems algebraically, it is section 08 in your book. I'm going to have an example here. This is actually the example that we graphed just a second ago. So we're going to solve this system by elimination. Notice I'm going to multiply that first equation by 4. So 2 times 4 gives us 8, negative 1 times 4 is a negative 4, and 9 times 4 is 36. The reason I did that is so that I have the same coefficient with opposite signs so that I can eliminate that y term when I add those equations together. So 8x plus 3x is 11x. The y term is eliminated because negative 4 plus 4 is 0, so we don't have that term anymore. And then 36 minus 14 gives us 22. And then our only variable left is x, and we get x equals 2. Once we know what x is, we can back substitute to find our y term. So our y is negative 5, and our solution is then 2, negative 5. Just like when we graphed, our solution was 2, negative 5 on the graph. So we can find that same solution algebraically. Okay. We can also do substitution to solve a system. This is a different set of equations. We have 2x minus 3y equals negative 2, 4x plus y equals 24. Notice in that second equation that y has a coefficient of 1, so we could actually solve that equation for y, and that way we know what y is equal to. It's equal to the expression negative 4x plus 24. We can use what y is equal to and actually substitute that in to y for the first equation. So and then we have 2x minus 3y. Now we're going to have 2x minus 3 times what that expression for y is. So negative 4x plus 24 equal to negative 2. Notice now the only variable that we have in our equation is x. So now we can distribute that negative 3 and get positive 12x minus 72. Combine like terms to get 14x. Also add 72 to both sides, and we get 14x equals 70, so x equals 5. Once we know what x is, we're just going to substitute x back into one of the equations. We have y equals negative 4 times x plus 24, so we can plug it in and get that we have negative 20 plus 24, and we get a y value of 4. And so our solution to that system would be 5, 4. So here are those graphed equations. We have 2x minus 3y equals negative 2, 4x plus y equals 24, and you can see our solution is that point 5, 4. And just showing that graphic representation of that system of equations. So now we're going to talk about distance between points on the coordinate plane. Remember how to do that. So when we have 2 points here, we then draw that triangle on the graph, and then we get those distances vertically and horizontally, and then we can do Pythagorean theorem. So we have 3 squared plus 4 squared equals c squared, and then we solve that. So c is equal to the square root of the distance in the y values, the distance in the x values, and then solving for that distance, which in this case happens to be 5. If we were just given 2 coordinates, we can just use the distance formula. Remember, that's x2 minus x1 squared plus y2 minus y1 squared, and take the square root of all of it. So for practice, you could find the distance of -2, -3, and -4, 4, and get that the distance is the square root of 53. So all of this is prior knowledge stuff, either stuff that you've learned in Algebra 1 or the distance that we've talked about in a geometry class so far. Now we're actually going to use this information to talk about our objective for the day of finding the distance between a point and a line. Okay, so first I just have an illustration of some lines and some distances. So for example, what if I wanted to find the distance between this point B and the x-axis? So my x-axis is that horizontal axis here. Notice I've connected point B to 3 points on the x-axis. So from B to this point A, we have a distance of 7.07 approximately. From B to point C, we have a distance of 5.59. And from B to D, we have a distance of 5. So we need to talk about which one would be the true distance between point B and the x-axis. Well, the true distance is always the shortest distance between 2 points. So the shortest distance that we can find is that BD segment, which is 5. Now, why does that happen to be our true distance? Well, notice that the x-axis is completely horizontal. This segment BD is completely vertical. Horizontal and vertical lines are completely perpendicular. So our perpendicular distance is the one we're always going to look at for true distance between a point and a line. So the distance between this point B and the x-axis, we would say, is actually 5, because it is the perpendicular distance between point B and the x-axis. So that takes us to the distance between a point and a line. So this concept means, how do we find the distance between this point C and this line AB? Well, we find that distance by calculating the perpendicular distance. So we would actually have to find that perpendicular line and then find the length of the segment between the point and the line of that perpendicular one. So notice that C to A is not the perpendicular distance, C to B is not perpendicular. That perpendicular line, the one that makes the right angle, would be our perpendicular distance. So it would be our true distance between the point and that line. Here's kind of an illustration of what that would look like in real life. This line right here is representing what's called a plumb bob, and it's a string with a weight at the end of it. And so if you hold the ball at the top, it will fall completely vertical or completely perpendicular with the ground. And we could see that distance to the ground. It tells us how straight something is. Like, for example, wallpaper, if you were trying to paint or put wallpaper up on a wall. So it would fall completely down, so you could tell if your wallpaper was crooked or if your painting lines were off. We have this perpendicular postulate. So this says, if given a line and a point not on that line, so given line M and then point P, which is not on that line, then there exists only one line through that point that is perpendicular to that given line. So through point P, this is the only line that I can draw that's perpendicular to line M. Okay, so here is a construction of what this looks like. We have a landscape architect notices that one part of the yard does not drain well. She wants to tap into an existing underground drain represented by line M. Construct and name the segment with the length that represents the shortest amount of pipe she will need to lay to connect this drain to point A. Well, based on our perpendicular postulate and our distance to from a point to a line, we know the shortest distance between the point in that line is going to be the perpendicular distance. So we need to draw that single perpendicular line through point A to line M. So what we need is we need to first construct a couple of points on that line. So here we have point B and point C. With our compass, we would have put our center of our circle on A, and then drawn an arc across line M. From that, we can then construct the perpendicular line through point A down through D. So this segment AD, or this line AD, would represent the perpendicular line through line M that would represent the shortest amount of pipe that she would need to lay. Now let's look at an example of what this would look like on the coordinate plane. So we have line L contains points at -5, 3, so line L, and 4, -6. So line L is this line that has a negative slope here. We want to find the distance between point P and line L. Point P is at +2, 4. Our first step would be to find the equation of line L. We've practiced this the past couple of lessons. So we would find the slope of line L, and we would find that that's -1. Once we found the slope, we would use a slope and a point to find the actual equation of that line. So we plugged it into slope-intercept form. M is -1, and we used the point for -6. We could have used our point -5, 3. It would have worked exactly the same way. We would have ended up with a y-intercept of -2. So our equation of line L is -x minus 2. Our next step is to write the equation of the line that would be perpendicular to line L through our point P. So we practiced this as well last week. Line L, we want the line that would be perpendicular through that point. So we know our slope was -1 of line L. So taking the negative reciprocal of that would be +1. And then we want the line perpendicular with a slope of 1 through point 2, 4. So using M is now +1 and a point of 2, 4, we get that our equation of line W is y equals x plus 2. Now that I have my two equations, I can now solve the system of equations and find what that intersection is. I need that point of intersection so that I can find that perpendicular distance. So in step 3, I need to solve the system of equations using the equation of line L and the equation of line W. So we know here we can eliminate that x term, so we get 2y equal to 0. So divide by 2, so y is 0. So the y value of point Q, or the intersection of our line L and W, is 0. And then we're going to need to solve for x, so we're just going to plug 0 back in for y, and 0 equals x plus 2. Subtract 2 from both sides, and we get x equals -2. So that's our point of intersection. Now our original goal was to find the distance between point P and line L. We now have the point of intersection of that perpendicular distance that we needed. So now I can just find the distance between point P and that intersection point Q. So now using distance formula between P 2, 4 and Q -2, 0, I can find that the distance is the square root of 32. And we would simplify the square root of 32. We could get the decimal approximation, or we would simplify that square root of 32 to be 4 square roots of 2. So my distance would be 4 square roots of 2 units, or approximately 5.66 units. And we have this guided practice question that I want you guys to try before class.